Hello everyone, I am Sourabh Shenoy, studying first year BE in Electronics and Communication at N.M.A.M Institute of Technology Nitte, Udupi, Karnataka. This is about the internship project on IoT based home automation solution provided by Emertxe Information Technologies Private Limited, Bengaluru, Karnataka. Now I start with my presentation with the following contents. That is, first I start with C++, then IoT, embedded systems, problem statement or what is the main objective of the project, project tools used, project requirements, project design, ADC that is analog to digital conversion, PWM that is pulse width modulation, Blynk app, Arduino IDE, project output, project demonstration which I am going to show in few minutes, and finally with the conclusion. So first I start with C++. As we all know, C is middle level language. That is, it can be used both as high level language and also as low level language. We learned about basic keywords such as int, which takes about 4 bytes, char, which takes about 1 byte, float, which takes about 4 bytes of memory, and double, which takes 8 bytes of memory. We also saw about basic structure of C program, data conversion, that is from decimal to binary, decimal to octal, decimal to hexadecimal, and also vice versa. Conditional statements like if, switch case statement, which is very helpful in C program, and loops, while loop, do while loop, for loop. We also saw about statements like continue statement, break statement, go to statements. So, continuing with the next slide, we also saw about the operators, arithmetic operator, that is multiplication operator, division operator, modulus operator, addition, subtraction, and second about logical operator, that is logical and, logical or, logical not, relational operator, greater than, less than, greater than or equal to, less than or equal to, not equal to, and assignment operator, bitwise operator, that is right shift, left shift, bitwise or bitwise and. We also saw about array, one dimensional array, two dimensional array, three dimensional array, and how the values are stored in the array. We also saw about the pointers, that is how to initialize it, how to declare it, and functions, that is function definition, function call, function declaration. We also saw about pass by value, pass by reference, then recursion, strings, that is initialization and declaration, about memory segments, storage classes. We also saw lastly about structure, preprocessor statements like stdio.h, conio.h, etc. And also about in C++. Next, we proceed to IoT topic. So, what is IoT? IoT is defined as the network of physical objects that can contain embedded technology to communicate and interact with their internal states or the external environment. So, here the IoT allows the objects to be sensed and controlled remotely across existing network infrastructure, creating opportunities for direct integration between the physical world and computer based systems like mobile phones, laptops, computers, etc., and results in improved efficiency, accuracy, and economic benefit. It also saves human effort and time. Next is IoT architecture. These are the stages of our IoT architecture. First is sensors and actuators, which I am going to talk in next slides. IoT gateway and data acquisition system. So, what is it? Data acquisition system collects raw data from sensors, aggregates, and stores it before transferring to an IoT gateway. Next is Edge IT, fog computing. Edge IT system is a platform that filters and pre-processes incoming data from the IoT gateway and minimize the volume or information that will be transferred to the cloud. Next is cloud computing. The cloud is cloud-based system that provides the processing power to the data that was transferred from an edge platform or an IoT gateway. Next, we see about what are the IoT requirements. First requirement is many devices, that is, multiple devices are connected. Next one is large scale. When we talk about many devices, the scale will be increasing. So, this is the large scale. Security, very important when it comes to IoT, because no one else other than us must get control over the system. No one must be able to get the data and hack our network. Next one is volume of data. Large amount of data will be flowing across the devices. So we must take good care of it. Next one is end-to-end integration. It is most important in IoT because data must flow from one end to another with integrity. That is, the data must remain the same. The data must not change. Now we move to the next slide, that is IoT challenges and its solution. The first challenge is addressing. Large devices communicate through addressing, that is, giving names. They must have their own address. When it comes to large number of devices, addressing becomes difficult. So, what is the solution for this? The solution for this is pub and sub method, which is similar to that of YouTube. When we subscribe a channel, we get a notification about their new video. So it works in the similar manner. The proceeding with the next challenge, that is scale. Here we collect the data from each devices. So collecting the data may vary from day to day. That is, one day we might collect more data and other day we might get less data. So this is called scaling. That is, increase or decrease in the collection of the data. So what is the solution for this? The solution is cloud computing. For example, here we use Blynk Cloud Console. Proceeding with the next challenge, that is connectivity. When it comes to IoT, internet connection is a must. So there might be huge internet traffic. So because of this, it increases the risk of losing the data. So server down may result in this. So what is the solution? Solution is storing the data in queues. So here, what is it? Here we keep the data in queues till we get the good bandwidth. So next the data proceeds itself. What is the next challenge? That is, next challenge is data volume. Here, since many devices are connected, large amount of data will be flowing. So it is very difficult to handle large volume of data. So what is the solution? The solution is same as second one, that is cloud computing, cloud storage. Fifth and the last challenge is device size. It is the most important because all the requirement cannot fit on the single board. So the device has its own frequency. It must have good sensors put on a single device. It will be very difficult to put all on the single IC chip. So what is the solution for this? The solution is we must follow the IoT protocol, that is AMQP MQTT. We must follow the IoT protocol mentioned by them. Proceeding with the next slide. Next is about embedded system. So what is it? Any combination of hardware and software which is intended to do a specific task can be called as embedded system. So for example, we can take washing machine and TV. Resources can be implemented on single IC. Here, it includes a variety of peripherals, namely timers, analog to digital converters, digital to analog converters, serial interfaces. Here, the same small size makes them very versatile. So these are the pictures of embedded system. Next is the types of embedded system. There are four types. Standalone embedded system. This type of embedded system, as the name suggests, does not require a host system like a computer or a processor, as it works by itself and displays data on the connected device or make necessary changes on the device. Next one is real-time embedded system. When an output is required at a particular time, a real-time embedded system can be used. When a task has to be completed on time or deadline for a project, this system comes to be a savior. There are two types of real-time embedded system, that is soft embedded system and hard embedded system. Network embedded system is the third type. When a program is running inside another device, a network is formed. So this is called as network embedded system. Here, a microprocessor or a controller controls the running program. A network is related to this system and they can be either LAN or WAN. Mobile embedded system. All the devices that are portable and working with an embedded system is a mobile embedded system. There are three types, that is small scale embedded system, medium scale embedded system, sophisticated embedded system. Next topic is components of embedded system. That is, the embedded system consists of sensors, A to D converter, that is analog to digital converter, processor, digital to analog converter, actuator, sensor. It measures the physical quantity and converts it to an electrical signal which can be read by an observer or by any electronic instrument like A to D converter. Analog to digital converter. Here it converts analog signal sent by the sensor into digital signal. Processor. Processors process the data to measure the output and store it to the memory. Digital to analog converter. A digital to analog converter, it converts the digital data fed by the processor to analog data. Actuator. It compares the output given by the digital to analog converter to the actual output stored in it and stores the approved output. When we talk of embedded system, it can be based on any of the three types, that is microcontroller, microprocessor, SoC, system on chip. Microcontroller, it includes processing unit, memory, and input output peripherals on a single chip. All these are included on the single chip. Next is microprocessor. Here it consists of processing unit where we have to interface other components like input output memories, timers externally. All these will not be integrated on the single chip. Next is SoC, system on chip, an integrated circuit or an IC that takes a single platform and integrates an entire electronic or computer system onto it. Next is embedded system requirements. The embedded system must be reliable, cost effectiveness. That is, it must not be very costly. Next is low power consumption. It must consume very low power compared to others. The processing power must be used efficiently and memory also must be used efficiently. Next one is challenges. Efficient input or outputs, embedding an OS, code optimization, testing, and debugging. So these are the challenges of embedded system. Next, we come across memory. There are two types of memory, that is random access memory RAM and ROM. So first we talk about RAM. RAM is an unstable memory which is used to store the data temporarily in its registers. The two main types of RAM are static RAM and dynamic RAM. SRAM, that is static random access memory, is a type of RAM that retains data bits in its memory as long as power is being supplied. Here, power must be supplied continuously. DRAM, dynamic random access memory. It is a type of semiconductor memory that is typically used for the data or program code needed by the computer processor to function. Next one is read-only memory. Read-only memory or ROM is a stable memory which is used to store the data permanently. It is also called program memory, where the user will write the program for microcontroller and saves it permanently. And finally, the program is executed by the CPU. There are three types, that is PROM, EEPROM, EEPROM. PROM, programmable read-only memory. It is also called as flash memory, in which we can read, write, and erase the program thousands of times. EEPROM, erasable programmable read-only memory. It is programmable read-only memory or PROM that can be erased and reused. Erasure is caused by shining an intense ultraviolet light through a window that is designed into the memory chip. EEPROM, electrically erasable programmable read-only memory. In the normal ROM, we can write the program for only once, but then we cannot use it again for multiple times. But here in electrically erasable programmable read-only memory, that is EEPROM, we can program the ROM multiple times. So these are the types of ROM. Next, we come to our project. What is the main objective of the project? The main objective of the project is to control the home devices using Blynk IoT app through the Blynk Cloud server, that is home automation. So, what are the project tools we have used here? Here we have used hardware components as well as software components. The hardware components are as follows, that is LDR sensor, LED, CLCD, Arduino Uno, Ethernet shield, temperature system, that is heater and cooler, water tank. The software components are Arduino IDE, Picsimlab emulator, null emulator, Blynk application, that is both mobile and web version are needed, and strong internet connection is a must. Next, project requirements. The project requirement number one is garden light control. It is based on LDR sensor. Here, during daytime, lights must be off, and during nighttime, lights must be on. Second requirement is temperature system control. By using Blynk application, here we can control the heater and cooler using Blynk app. That is, we can turn on and off the heater and cooler. Here we also print the notification on the mobile application on the dashboard. Here, if the heater is on and the temperature rises above 35 degrees Celsius, then a notification is sent to the mobile phone and the heater is turned off automatically. Next requirement is water tank control. Here, the tank inlet and outlet valve is controlled using button widget on our phone. Suppose the volume of the water is less than 2000 liter, then a notification is sent on the app that the water level is less than 2000, and then inlet valve will be on automatically. After this, once the volume becomes 3000, that is water level is full, inlet valve will turn off automatically and a notification that water level is full and inlet valve is disabled is displayed on the app. Next is how the garden light control takes place. It is based on LDR sensor. LDR is used to indicate the presence or absence of light or to measure the light intensity. During day, lights must be off, and during night time, lights must be on. During night, the resistance will be more, so the LED will turn on. Similarly, during the daytime, resistance will be less, so the LED will turn off. So as it becomes darker and darker, brightness of the LED increases, and more brighter the sunlight, brightness of the LED decreases. LDR sensor sends notification to Arduino Uno, and Arduino Uno sends signal to lights to turn on. So here the maximum is the resistance during night, LED will turn on. Minimum the resistance, that is if I slide this down, LED will turn off. So analog to digital conversion. Here, the analog signal is converted into digital signal with the help of ADC, that is analog to digital converter, and the output will be pulse width modulation signal, that is PWM signal. Steps in the conversion: sampling, quantization, encoding. This is the block diagram of analog to digital conversion. Sampling. It is a process of measuring the amplitude of continuous time signal at discrete instants, converting the continuous signal into discrete signal. Quantization. The result of sampling is a series of pulses with amplitude values between the maximum and minimum amplitudes of the signal. It can be infinite with non-integral values between the two limits. Encoding, the digitalization of analog signal is done by the encoder. After each sample is quantized and the number of bits per sample is decided, each sample can be changed to an n-bit code. Encoding also minimizes the bandwidth used. Next is pulse width modulation. Pulse width modulation or pulse duration modulation is a method of reducing the average power delivered by an electrical signal by effectively chopping it up into discrete parts. The average value of the voltage fed to the load is controlled by turning the switch between supply and load on and off at a fast rate. The formula used is step size is equal to input range divided by 2 to the power resolution. The PWM output voltage formula is mentioned and duty signal is also mentioned here. Next is the temperature control. Here we read the temperature from the temperature system and display it on the CLCD and also on the mobile app. We can turn on and off the heater and cooler using the app by the widgets. This is how the process takes place. This is the block diagram. Here, a notification is printed on the mobile application on the dashboard if the heater is on and if temperature rises above 35 degrees Celsius, the notification temperature is about 35 degrees Celsius, turning off the heater will be printed on the mobile phone and the heater will be turned off automatically. When the heater is on condition, when the heater is in on condition, heater on will be displayed on CLCD. When the heater is in off condition, heater off will be displayed on CLCD. Similarly for the cooler. Here, the formula must be used for converting digital values from ADC to temperature degree Celsius. This is the formula used for the conversion. Next is water tank control. Here we read the volume of the tank and display it on the CLCD and at the same time also on the mobile application. Here we control the tank inlet and outlet valve using button widget. The message is displayed on the CLCD whether the inlet or outlet is on or off. When the inlet valve is in on condition, inflow on will be displayed on the CLCD. When inlet valve is in off condition, inflow off will be displayed on CLCD. Similarly as for outlet valve. This process takes place by serial communication. Serial communication is a communication method that uses one or two transmission lines to send and receive the data, and that data is continuously sent and received one bit at a time. Since it follows for connections with few signal wires, one of its merit is its ability to hold down on wiring material and relaying equipment costs. This is the block diagram of how the process takes place. This is the block diagram of how serial communication takes place. Here, suppose the volume of the water tank is less than 2000 liter, then a notification water level is less than 2000 liter, water inflow enabled will be disabled, will be printed on the app dashboard, and then inlet valve will be switched on automatically. Then once the volume becomes 3000, that is full, water level is full, water inflow disabled will be printed on the dashboard, and the inlet valve will be turned off automatically. So this is the picture of serial remote tank, and the message which will be printed on the CLCD screen. Our next topic is Blynk app. So what are the steps for using Blynk app? First, we created Blynk account in web version. Then we created the template as home automation as shown in the picture here. Then we added a new device. Then we copied the template ID, device name, and authentication token, without which the home automation project, which we are doing now, won't work at all. Next is we added the data streams, that is switch is connected to V0 pin, temperature connected to V1 pin, virtual pin V2, virtual pin V3, virtual pin V4, virtual pin V5, and the last one is string V6, that is virtual pin V6. Next, we set up the widgets required in the mobile app, and hence we are ready to control the devices. That is cooler widget, heater widget, temperature gauge, notification panel, inlet valve for water tank, outlet valve, and water volume gauge. The next topic is Arduino IDE. Here, first we install the required library files like spi.h, ethernet.h, blink simple ethernet.h. Then we code the required part and then save the file. Then we compile it. Here, this is the compiling one. Then we export the compiled binary, and then we load the hex file in Picsimlab simulator. So then our project will work. So this is how Arduino IDE looks like. This is the compile. This is file, edit, sketch, tools, help tab. Let us proceed with the next part, that is project output. So this is how my project output looks like. This is, however, the pictorial representation. Next, I will be demonstrating the project part. So now the project demonstration. Let me minimize the presentation screen. Let me open Picsimlab, serial remote tank, and A power mirror to mirror my phone. So we must ensure that the device status is online. Now it's showing offline. So let us see the coding part. So this is the coding part. So this is the programming part of LDR. This is the header file of LDR. This is header file where we define the pins which we have connected. This is the coding part of the serial tank. This is the header file of the serial tank. This is the coding part of the temperature system. And lastly, this is the header file of the temperature system. So here we have integrated all these in one file. So let me proceed with the demonstration. Here we can see that it is connected to COM2 port. Here serial tank must be connected to COM1 port since they are pairs. So here we click connect, and now I load the hex file. So now it says online. Device status is online. So as soon as it gets online, we can see that our project is working. That is, volume of the tank will be filled. We can see that water level is less than 2000, water inflow enabled. Here this notification will be printed on the mobile dashboard. We can see the volume of the water tank. Here the inlet valve is on, and now automatically it gets turned off because when the water level is full, water inflow will be disabled. That same notification will be printed on the mobile dashboard. So now inlet valve will be disabled automatically. So this is how the water volume tank can be controlled. So next I proceed with the garden light control. So this is how garden light can be controlled. That is, during night time, resistance will be more. So LED brightness also will be more. More the brightness, more will be the resistance. So if I slide down, that is, as the resistance decreases, brightness of the LED also decreases. So this is how we are controlling the garden light. So next, let me proceed with the heater and cooler part. So now, let me on the heater. So as we can see, the temperature will be displayed on the CLCD screen. And as the temperature increases above 35 degrees Celsius, the heater will be turned off and the temperature decreases to the minimum value, that is room temperature. Here it is 27.5 degrees Celsius. So this is how we control the home appliances like garden light, water volume, and heater and cooler. So now let me on the cooler. So as I on the cooler, this will be turning as we can see. So this is how the project works. So now I am done with the demonstration part. Here I have covered all the requirements of our project. So let me minimize. So I am done with the demonstration part. So let us proceed with the conclusion. So what I have learned from this internship. So now I am able to use Arduino IDE and code in embedded C++. Now I am able to use Picsimlab emulator and Ethernet shield since Arduino doesn't have inbuilt internet or Wi-Fi port. And I also got knowledge on how to make career in IoT field. I also understood about IoT, embedded system, microcontrollers, microprocessors, and different memories, that is RAM, ROM, and its types. I understood the working of Arduino LDR sensor, LED, temperature sensor, serial tank, and how to implement these in real life. And most important, I am confident to make Arduino based projects. And I have learned the new concepts like PWM, that is pulse width modulation, analog to digital conversion, and how analog to digital conversion takes place, and also about serial communication. So, lastly, I would express my special thanks to Emertxe team for providing me with this internship opportunity. So now I end my presentation and demonstration. Thank you one and all.